Let's see what we got. Advent of Code 2024, day 24, the square puzzle. Day 24 is called Crossed Wires. You and the historians arrive at the edge of a large grove somewhere in the jungle. Okay. After the last incident, the elves installed a small device that monitors the fruit. I guess from 2023, day 23. While the historians search the grove, one of them asks if you can take a look at the monitoring device. Apparently, it's been malfunctioning recently. The device seems to be trying to produce a number through some Boolean logic gates. Oh, okay. Each gate has two inputs and one output. The gates all operate on values that are either true or false. AND gates, OR gates, and exclusive OR gates. Okay. Just scanning this really quickly to make sure he's not doing any tricks here with the names and the actual actions, but it looks like they do what it says on the tin, right? Gates wait until both inputs are received before producing an output. Wires carry I don't know how they do that. But we'll just, we're in Magic Land where gates just know when the input is available. Wires carry 0, 1, or no value at all. There are no loops. Once a gate has determined its output, the output will not change until the whole system is reset. Each wire is connected to at most one gate output, but can be connected to many gate inputs. Okay, so this is how the magic happens. Apparently, these are tri-state gates where we can have no value. This is going to be interesting. Rather than risk getting shocked while tinkering with the live system, you write down all of the gate connections and initial wire values, your puzzle input. So you can consider them in relative safety. For example, oh, okay, so we have two different styles of input. Let's get the input. Okay, so I can see this. There's 313 lines. Let's take a look at it. Yeah, okay, so we have a bunch of values here, and then we have a blank line, and then a bunch of gates, okay? Oh, not too many. Well, yeah, 313 minus whatever the inputs are. Because gates wait for input, some wires need to start with a value. The first section specifies these values. Okay, so we could just walk our way through the whole thing. And maybe we could just make a little recursive solution or something where you say you get this input, because it looks like the inputs have various 3-letter names. And so we could say, okay, for VVQ, let's look at what the VVQ is. And it's going to be, I just saw it here. So VVQ is the result of X29 and Y29. And then so we could just say, okay, if we're trying to get JVP, we get DTJ, which is somewhere. I can't see it, but I'm not going to look for it. So then we say, okay, we're asked DTJ for its value. And so we just walk our way through the tree that way. Now imagine this is just one giant tree. Okay, the first section specifies these values. For example, X00:1 means the wire named X00 starts with the value 1, as if a gate is already outputting that value onto that wire. Okay, the second section lists all of the gates and wires connected to them. For example, X00 and Y00 yield Z00, describes the instance of an AND gate. Okay. In this example, simulating these gates eventually causes a 0 to appear on wire Z00. Right? Okay. Ultimately, the system is trying to produce a number by combining the bits on all the wires starting with Z. Z00 is the least significant bit, then 01, 02. Okay, so we could just ask for the Z values and then work our way through the tree. In this example, 3 output bits form the binary number 100 or 100, which is equivalent to the decimal number 4. Okay, and we have a bigger example. If you're waiting for values on all wires starting with Z, the wires in the system have the following values. Okay. Combining the bits for all the wires starting with Z produces the binary number this. Converting this number to decimal produces 2024. Simulate the system of gates and wires. What decimal number does it output on the wires starting with Z? All right, we got the puzzle input. How do we want to do this? We want to create a gate, maybe? Which is and, or XOR. And then maybe what we could do is have a system, which is a hash map. It's where we can look up the name of a wire and find out well, this would be a gate type, maybe. Maybe we do that. Gate type, and then we have a struct gate, which has a left, a right, and a gate type. And then let's see if that works. So we map a string to a gate. So I can say, get me Z00, and then it'll look up that gate info and then ask the system for the values in the other ones. And then, oh, no, that's not going to work. Because we have X00 and Y00. Right? We have all the X's and Y's up here. So we need to be able to look up a value. Right, because if we're here, right, we're look up TNW, we want to look up. Oh, I guess we could do that if we create a system, right? We can say struct system. No. I want to be able to just look up the value directly. I want to just say, okay, system dot get this string, the value it is, and I just want to return one of these guys. I just want to, okay, so maybe gate. Maybe we do it this way then, string the string. Right? And this is just a gate like this. And then we can also have a value, which is going to be 0 or 1. You wait. Now let's make it. How big did this get? This is getting up to 19. Grep Z in the input. Oops. I see Z42. Okay, let's make it an U64. How's that sound? Gate type const bool. Oh, I see. Yeah, because these are all going to be zeros and ones, right? I don't know if I want to use bool because I want to be able to do bit shifting, right? Because we're going to say get 0 and then get 1 and bit shift that up, and then get 2 and bit shift that up. But I like the idea of const. Let's use that. Okay, so now we map strings to gates, and then what we do here is grab the lines. We're going to loop over the lines. It's either going to have a colon space, or it's going to have space, arrow, space. The blank line gets stripped by read lines, so we don't have to worry about that one. So for line in lines, if let sum left right equals line dot split once on colon space, then we know we have a constant value. Else, if let sum left right is equal to line split once on space arrow space, then we know we have a gate else we have a bug. Yeah. Okay, so for the value, we want to grab the string and then just insert the value into the hash map. Self system insert left, right, parse, unwrap. Oh, right. We're going to have to create a from stir for this thing. Yes. Okay. So impl from stir for gate. It might be a number if let some okay u64 equals s parse. Oh, not u64, value u64. Then we're going to return okay self const value. It should be a 0 or 1. Otherwise, we're going to split on space. That's split white space. Collect back. I'm going to match words of 1. It could be, oops. And there's going to be a self and words 0. Oh, that's probably, these are probably strings, right? Yeah. Into words 2 into. And then we have OR and XOR. It doesn't like this. There's some syntax error going on here. Let's save it and see what I can read. Oh, I have a syntax error all the way up here. Oh, I used the wrong arrow type. Oh, these all need to be okayed. Yeah, got it. Like that, and then hash map is not found, so let's add that. Oops, we still have a problem. This maybe you can do into here. Use a semicolon. Non-exhaustive, true. Okay. Okay, we're getting there. Now all we have are warnings left. Okay, so now we just need to figure out this guy. This would be the same thing, right? Self system, insert, left into, right, parse, unwrap. Okay. Why is it telling me this? Oh, it's saying I'm not actually using them. Okay, so now what we have is everything. Let's see if we can print this out. Println self system. Let's see what it looks like. Left is the gate and right is the name. You got it. You got it. I was just copying from the lines above. Right into is left parse. Thank you. Hopefully I would have seen that in the printout. So in our actual input, JVP, I'm just looking at that first one, is the result of ORing DTJ and VQQ. Y20 is a constant 0. Well, it's used there. Yep, it's a constant 0. Let's take another look here. Z12 is the result of adding KSN and NFT. NFT. Okay. All right. I think we successfully parsed. So now we should just be able to get the values for each one. If I can say up here, fn get value self wire, which is just a reference to a string. I don't know if I'm going to have to be able to use strings, but I know Rust prefers reference to stir wherever possible. I'm just going to return 0 for now. And then what we'll do is we'll just run through here in part 1 and see if we can get the values for each one of the outputs, right? We care about all the Z's. So we can say for, how many Z's are there? I guess we could collect those, right? We have them in the values. Let's see. Z's equals self system keys filter key starts with, do I do that way? And then collect back. And then I want to sort them. And then print them out. So I want to make sure we have them. Get rid of this guy. Okay, so 45 is the last one. All right. And now we can just get them in order and shift. For Z in Z's, let result is equal to 0. We can do this. We can say shift Z in Z's enumerate. I mean, I think I could just construct. I could just go 0 to 45 and then construct the thing that way, but this seems easy enough. We can just say result or equals self get value of Z shifted by shift. And then this is just result. And then all we need to do now is iter, right? Or into iter, but this is fine. It's a reference to a string. Okay, so now that's going to be 0, hopefully. Yes, it is 0. And now let's see if we could just get the value of things. How do we get the value of something? We have to match self. Should I just assume that we're only going to pass in valid wires? So I could just do that. And then we can say A and B here. And it's going to be self get value A and yeah, because it's all going to end up being 0s and 1s. So we can just use the bitwise end self get value B. Right, and we can do that or exclusive or, and the const is just the value. Let's call it C. Right, so this is or, and this is exclusive or. I forgot to put the A's and B's. And what are the? Oh, these are okay. Interesting. Oh, I guess maybe if I had said ampersand here, then that would change that. Yeah, okay. Let's do that. and then I'll have to deref this guy, right? Yeah. All right. I mean, we got a number as opposed to a panic, right? As opposed to an overflow error or something like that. Hey, that's the right answer. Okay, that was pretty neat. That was a fun one. I can see how you can do this one by hand, right? You could just trace the wires out. You don't need to actually write this code. But writing the code's the whole point. That's where I have my fun. All right, git status, git add source, git commit -am 2024, day 24, part 1 in the bag. Let's see what part 2 is. Scoop says, just wait for the fun, in quotes. Wait for part 2, says Nicelaa. All right. After inspecting the monitoring device more closely, you determine that the system you're simulating is trying to add 2 binary numbers. Oh. Specifically, it's treating the bits on the wires starting with X as one binary number, treating the bits on the wires starting with Y as a second binary number. Oh. And then attempting to add these 2 numbers together. The output of the operation is produced as a binary number on the wires starting with Z. All right. That makes sense. In all 3 cases, wire 0, 0 is the least significant bit, then 1, then 2, and so on. Okay. Initial values for the wires in your puzzle input represent just one instance of a pair of numbers that sum to the wrong value. Ultimately, any 2 binary numbers provided as input should be handled correctly. Oh, okay. Why did they sum to the wrong value? For any combination of bits on wires starting with X and wires starting with Y, the sum of 2 numbers the bits represent should be produced as binary numbers starting with Z. Okay. Now, I understand this, but why they the wrong value? Oh, okay, here we go. If the system were working correctly, then after all the gates are finished processing, you should find 24 on the Z wires as a 5-bit binary number 11000. Unfortunately, your actual system needs to add numbers with many more bits and therefore has many more wires. Based on forensic analysis of scuff marks and scratches on the device, you can tell that there are exactly 4 pairs of gates whose output wires have been swapped. A gate can only be in at most one such pair. No gate's output was swapped multiple times. For example, the system below is supposed to find the bitwise AND of the 6-bit number on X00 through X05 and the 6-bit number blah, 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 and then write the, yeah, okay. Supposed to AND everything together. However, in this example, 2 pairs of gates have had their output wires swapped. I can see it's supposed to go to 0, but it went to 5. This is 5 and it went to 0. Oh, also this one here and here. Okay, I think I understand the problem. Your actual system is much more complex than this, right? But if we're just adding, I mean, there's a known way to add with gates. I don't know it off the top of my head, but we could figure it out. Your system of gates has wires has 4 pairs of gates which need their output wires swapped. 8 wires in total. Determine which 4 pairs of gates need their output swapped so your system correctly performs addition. What do you get if you sort the names of the 8 wires involved in a swap and then join these names with commas? All right. Well, I mean, let's think about how we do addition. How do you do addition? We have 2 inputs, A and B, and we have a carry flag. Right? This is the way we do addition with circuitry. And we have output of a sum and an output of a carry out. So this would be carry in. So we can just, come up with all 8. There's only 8 possibilities here. One, 1, 0, and 1, 0, 1. Oh, I did 1, 1, 1. There we go. So these are the 8 possibilities. The sum of 0 is 0. This is 0. So, and the reason you can go from 8 to just 2 bits, 4 states, is because many of them end up with the same value. Like here, this one is 1, 0, and this is also 1, 0. right? The sum is just how many bits are set. So it'll be 0, 1, 2, or 3. This has 2 bits set, so we set the carry, but the sum is 0. This just has 1. This is 2. This is, oops, this should be a bar. This is also 2. And this is 3. Come on. Right. So we know that summing is basically exclusive OR. And here the carry is an AND of these two. In fact, it's also an AND of these two as well. We look at the carry. But I think we could just look at the gates we've got. We should be able to see that, right? Let's look at, in the input, we have x0, 0. Let's just check 2. I'll pull it up over here so we have it. We can look at the side by side. So x0, 0 is ANDed to get WHB. So we'll just do 2 bits, just to, because the 0 bits won't have a carry in, but the 1 bits will have a carry in. Yeah, Scoop says start with 0, 1. Right, but if I do the 0, 0, then it'll lead to the carry in. So I'll do it one step at a time here. So x0, 0 and y0, 0 go to WHB. But there should be another set of inputs, right? Yeah, exclusive OR, right? x0, 0, XOR y0, 0 goes to the Z bit, right? So this is our output of our first bit. So now what we need for 0, this will probably feed into, because we'll need an exclusive OR, no, for the sum, well, you need it for the carry. This is the carry bit. Okay. So now WHB is going to lead into 01. So if I look at x0, 1, right, we have an AND, just like we did for bit 0. Goes to BDF. That's the sum of these 2 digits. And then we'll have another one for exclusive OR. But now it's going to JJD, right? Because we need to include the carry bit here, which means WHB is going to be part of it now. WHB. Yeah, JJD and WHB is WBW. And then we'll need JJD. XOR WHB is 0, 1. Right. Okay, so that makes sense. JJD XOR WHB is 0, 1. All right, so this is the pattern we're looking for, right? Where we have a bit and another bit goes to a wire, a bit exclusive OR another bit goes to a wire, and then we need to see that the exclusive OR goes into the carry bit of the previous one and gets us the next our current bit that we're looking for, and then the AND goes into the carry. Right, so BDF. Yeah. So this goes to carry. And this goes to the carry. Right? And this is the sum. This is sum out. Okay. And this goes to the carry. BDF has your first OR gate. Yes. Oh, okay. BDF or WBW goes to QCF. Okay. So that's probably, let me just put a space here, line things up. So this is the carryout. Thank you for, I almost missed that one. All right, so every bit of output has 5 gates associated with it, except for the first one. We have these 2 for the carry, for the sum, and then these 2 for the carry. Okay. And so what we need to do is, yeah, I can totally see how just drawing this out on paper makes it super easy to figure out. You can just see which ones are swapped. Like if these 2 were swapped, then JJD wouldn't be going to the XOR and it would be going down here, and that would be bad, right? I guess technically this one is the carryout for bit 0. But okay, so let's see. How can we figure out which bits are bad? Because we should be able to do that and then narrow down our search space that way. We should be able to just pass in. Let me just think about this. If we swap any 2 gates, Scoop says, I actually showed her how to output a graphviz dot file and convert it to SVO. Oh, cool. I'm sure that was a lot of fun. If we have zeros input here everywhere, everything is going to be 0. So it's all going to work, right? Or it'll all look right, even if bits are swapped. So we need at least a 1 somewhere. So if I change the input, and I can't do that easily because I have this system here where we just look up the constant. Maybe we change. Maybe we split this apart. What we do is we have an X and a Y value. And store those there and then look them up here if we're looking for an X or a Y. Instead of storing it as a constant, we do need to store whether it's an X constant or a Y constant. And we do need to know which bit it is. So maybe the constant gets split up that way. And then we can look up here. And I can just set the values directly during parsing. Scoop says other people made a net list and imported it into electronic software to visualize it. Oh, that's really neat. That's really neat. I don't have that software on here, though. So if we change constant to be a string, actually, we could just make it a char, right? So this will be x, xy, comma, value, wire, number. Right? We won't parse the value. How do we want to do it then? Oh, we already know. Yeah, let's leave it this way. Okay, let's leave it this way. But when we do this bit here, what we want to do is store X or Y correctly. So if left starts with X. Idle Star Astronomer says, I ended up rearranging the input file by hand so all the gates for each adder were grouped together. Oh, that's smart. Yeah, and then the errors just pops out right out, right? Well, what I'm gonna do is I'm gonna try to set 1 bit at a time, bit by bit, and then at least I'll know which Z output is incorrect. So let's do this. Let val u64 equals right parse. Oh no, this is a gate. Unwrap. All I want to do is get the value, and that it's hurting my brain. No, I could say let gate : const val equals this, else panic invalid const line. Yeah, do that, and now I have the value, and I'll just parse gate unwrap. Still unknown. If I do that, okay, now it's U64. Okay, so we're going to insert it here, gate const val, but we're also going to store it in X or Y. If left starts with X, then we're going to say, oh, I need to know what bit it is. I mean, it's not necessarily in the right order. Yeah, it's all, no, they're in order. Let bit is equal to left of one ... parse usize unwrap. Right, and that's a usize. And if it starts with an X, then we're going to say X or equals val shifted by bit, else self X, and self Y or equals val shifted by bit. Don't forget the semicolon. You could do it after you parse and use get value for it. Oh yeah, that would be smarter, right? That would be a lot easier. All right. So this will actually be in part 2. Yeah, we could do it here. For v bit in 0 ... Oh, we have to do this thing here where we get the X's and Y's. Actually, we could just do this, right? We can just extract this code here. Fn get. No, get. I have to get value. Get number, self, which char, U64, and when I can just do this. It's Scoops is suggesting factoring out part 1 to take a line type X, Y, or Z. Yeah, that. I was thinking I can't do that because then get value has to do the work, but you're right. We could just do that. We can just do this. And then which is just going to be here, right? And then I don't want to call it Z's. I want to call it wires. Wire, oops. And then results. Right, and then down here we just call get number. For Z. Oops. So this should still work. I mean, it kind of does. I think that's the right number. 2854. Yeah. Okay, that's the right number. Well, it's the wrong number. So now we can say self X is equal to self get number on X. and self y is self get number on y. And then up here, instead of just looking up or returning this, I want to know what, I want to know what the wire is. I want to base it off the wire's value and just retrieve it from and I don't want to have to parse it each time. So yeah, I'm going to stick the wire ID in here in the gate. Except we don't know it at this point. We do know it here. The wire ID is passed to get value, but as a string. Right? So I'd have to parse it each time. Right? I'd have to say let a bit is equal to wire one dot dot parse U64 unwrap. I mean, this is running fast enough. Maybe it doesn't matter. And then we're going to return the bit we care about, which is going to be if. Oh, and then we need to care. We also need to look at which wire we care about. Match wire. Oh, if wire starts with X. See how painful this is. Then we're going to look at X is self X, and 1 shifted by bit equals 1 as U64. Else the other one. Oops. And I can do this. Okay, so Scoop says, how's the const going to be different? Well, I want to play with the consts, right? I want to change the const in part 2. I want to be able to say, you know, self x is equal to 0, self y is equal to 1, and now add them. Self get value. Oh, get number. Z. And print that. And see if it's 1, right? So we should be able to do this. Cargo bacon run. I broke this though. What are X and Y? Oh. Yeah, 0, 0. Okay, so this get number isn't working. Oh, yeah, because we don't have it set yet. So in order to set it, we need to have it set. In order to have it set, we need to set it. Nice. Good old circular reasoning. What I can do, maybe I can do it this way. I can make it an option. And that way we can just look it up this way here. If self x let sum x is equal to self x, then we do that, else we return C. right? Oh, X now and Y. And now this needs to be sum. It's a good thing that X is not dependent on Y, otherwise that won't work. We do this, and we do this. And this is sum 0 and sum 1. And somehow this is ending up being 2. We did get these values in there. Just return C if X and Y are 0. Yeah, I guess I'm always going to put something in there special, right? I would like to get this to work, though. Maybe I need parens around here. Oh, right, not equal to 0. You're right. I'm checking all the way at the bits location. There we go. Okay, and 2854. Okay, so I think we're good. I did add 1 and get Z. And get 1. So that worked. So what I want to do now is check each bit. How many bits are there? We can let y's equals self system values, filter value wire dot starts with y, and this will tell me how many there are. $43 bits, yeah, but I don't want to assume, right? Different people have different input. I guess we can kind of cheat and just count them. Because they are going to be consecutive for y in 0.y's. We'll set self y is sum 1 shifted by y, and then try to add it. Let sum is equal to self get number z, and then we can compare to see if the sum is actually what we expected. If sum is not equal to 1 to the y, then println expected this got sum. Okay. And we can check each bit, bit y. And this will be 1 shifted by y. Oh, there we go. And didn't like that. Wire is, a gate. Oh, not values, keys. Aha! And then we panicked. Why do we panic on line 96 there? Oh, is this one? This one is probably U32. It's saying no information available. U64. There we go. Okay, so we now know the 4 bits that got swapped. How in the world does that help us? We can look at how would we do that? How would we check to see which gates we're actually messing around with? Right, we can say, okay, bit 7, we know that something in the bit 7 stuff failed. So we can look at the input, right, for bit 7, X07, and we can say, okay, so maybe this isn't supposed to be CDS, maybe it's supposed to be something else swapped. But what was swapped, the outputs or the inputs were swapped? Whose output wires have been swapped? Yeah, so maybe CDS is wrong. Maybe it's supposed to be whatever the other one is. SDJ, maybe SDJ and CDS got swapped, for example. But there's, as we saw as we worked our way through it, there's actually 1, 2, 3. Well, I mean these 5 outputs, right? WHB, BDF, JJD, WBW, and QKF. Although QKF does not affect the sum. So it's actually going to be these 2 that modify the sum, and then this gets involved with the carry. So it could be the bit before, right? So bit 6 could be messed up with the carry and passing the wrong carry value in, and that affects bit 7. So actually, let's play around with that a little bit. Let's take a look at the input and take a look at bit 6 and see what it looks like. So we start off with exclusive OR. And then the other pair is an AND, right? Well, let's keep it in the same order as here, and then there should be this, right? So we should see SSV. We have JMK or SSV goes to RKV. And we should see a QMT. Actually, I should look for SSV in another location, right? It could be, no, there's only those 2. Okay. So QMT is the next one. Oh, we don't need that. We have a JMK that might be coming in from bit 5. Do we have another QMT? No, just those 2. Oh, wait. Right, that's that one. GTN XOR, GTN XOR QMT goes to Z06. We know that bit's okay. This is the sum out. So let's see, let's put it in the same order again and see what happens. This looks all correct. And then we have JMK or SSV, right? WBW is one side of the AND, which is JMK, that works. And then the other side is BDF, which is the AND of the 2 bits. So that all looks good. I should set no number just to get rid of the numbers, yeah. I'd also have to set no relative number. No new, no RNU. Yeah. All right, so this looks okay. Let's take a look at 07. We have CDS. And then there should be, oh, that was the exclusive OR. There should be an AND as well. Here it is. Okay, we're going to figure out what's wrong here. And then we should have, so GTN XOR QMT. So there should be something. GTN is probably the carry from the previous one, which is RKV. So there should be an RKV and CDS. So let's see what SDJ, let's look at that one first. Oh, look at that. So that's going to Z07, and that's wrong. Right? This should be the carry out, and it isn't. SDJ is here and here. Yeah, okay, and then CDS is and RKV goes to NPH. And we're missing the exclusive OR now. That's the only other one. Here it is. That goes to RTS. So looks like RTS and Z07 are swapped based on this. So let's see if we can manually try to swap those and see if those go away. All right, we could kind of cheat here. If wire equals, what were the two? Z07 and, let's pull it up over here, and RTS. Let wire equals, if wire is RTS, then it's going to be Z07. Else, if wire equals Z07, then return RTS. Else, just return the wire itself. All right, so we'll just swap them here manually, and then run it over here. Oops. And see if that fixed. Yeah, so that fixed bit 7. Okay, so I see how we can do this just manually. If I could just look at each one of these bits, so I can look at 12, 26, and 34 and stick the swaps in here. But then to get the output, then I'd have to collect all these manually. What I would like to be able to do is say, okay, we hit bit 7, we know it's wrong. Can we add a swap rule for some of the wires? And we don't know which ones they are, right? Because without going through this whole thing, I guess there's only 1, 2, 3, 4, 5 that we care about of the outputs. So we could look up the output for these guys, get these two things. Yeah, we'd have to look for a gate. Because I have these backwards, right? I have this goes to here. So I can't just do a lookup for that. I have to say, go through all the values and look where we're doing an AND of these two gates, of these two wires. Let me comment this bit out here. And add a swap, which is going to just be a hash set of string. And we'll just throw in the swaps. Oh, no, we need to map. Because we need to know what we're swapping with. Right, so we need a pair of strings. Oh, no, that's not going to work. Let's do a map. Right, and then we can say here, get value, and then we can say if let sum alt equals self swapper get wire. And then it's alt else wire. Right, this will work regardless. Scoop says you already know the output has to be an exclusive OR, and the inputs have to go to AND and OR. Yes. It's meanders. Being a NeoVim user, should you use Avante.neovim? I don't know. I've never heard of Avante.neovim. Good question. Right. Yeah. So we do know that um, SDJ has to go into an OR gate. SSV has to go into an OR gate. And then we do know that the 2 bits have to have an AND and exclusive OR, and the outputs need to go into specific types of gates. This has to go into an exclusive OR and it has to go into an AND with the previous carry. And we know that these are all true. Can we scan through and find all of that information? I wonder if we can. I wonder if we can just write a little bit of code that says, okay, I've got X01 and Y01. I need to find, that's the thing. I need to go backwards and find the gate. Okay. Oops. Let's see if we can find the gate for these guys. And there has to be an AND gate and an OR gate. Yes. I can scan the system, but I have to look it up by value, right? And the value doesn't have to have these gates in any specific order, right? This could be Y06 and X06. We're going to say for KV in self system, ampersand self system, right? This is the output and this is the 2 inputs. So we're going to look for an AND with the whatever Y we're on. Let X wire and Y wire equals format bang X Y02 comma format bang Y Y02. All right, so these are the 2 wires. We can look in the values now. If and get the input. Oh, we can do it this way here. We can save it that way and then say if matches bang gate and X wire Y wire gate V or matches gate and Y wire X wire V. I guess we could do it the other way around, right? We can just do it this way with an OR statement here. Then we found the AND gate. If we don't find the AND gate, Scoop says V comes first. Println found V. Let's just do this. Let's see what output I get. Oops, unclosed delimiter. Oh, because it's here. Oh, it's finding the ANDs that oh, it's not. Wait a minute. That's weird. Why is it finding this? At wire K. I'm missing something. It's probably in the warning here. No value can match this. Oh. Oh, really? Oh, this is because it's... So I do need to do this way, right? Let's just do this and see if we can find it. Consider cloning. Okay, I can just say gate and gate is equal to gate and X wire, Y wire, right? And then I have to implement equal and partial equal. V equals and gate. And I have to clone these. 1. Yeah. Gate and left right if left is equal to X wire and Y is equal to right wire. Wait, you can put that kind of thing in a matches statement? I didn't know that. I knew you could do it in the code part of it. I mean the normal match statement. If left is equal to X wire or right is equal to Y wire, or left is equal to Y wire and right is equal to X wire. Which one needs to be derefed? The left and the right? Yeah, okay. Oh, derefed. I re-refed it. Okay. All right, so we found the and, which is this thing. So now we know that this needs to go into an OR gate somewhere with the output of the and. Okay. I'm going to have to, this is going to get kind of weird because we have to search through this thing here several times. Archangel, thank you for the follow. Welcome. Maybe what we do is save it and then break, because we should only find one, and then after we get that one we can find the exclusive OR. Oh, how should we do this? I'm trying to think of maybe we can extract this into a separate function and say, look up something. And then pass in the gate I'm looking for. Can I even do that? Let me try that. I don't know if this is going to work, but I mean, we can definitely do it per gate. Fn find gate self, and then here, I don't know, gate. Gate. Option gate, because it might not find it, right? And that'll be the clue that something went wrong. This is finding an AND gate only. We can say this. Oh, no, I can't. Is there an easy way to do this? Obviously with a macro, right? I could just build a macro that'll generate these functions. Oops. And then this will just be return some V. Oh, V is going to be reference to a gate. Yeah, that's fine. None. That might give me a headache in terms of the bar checker. We'll find out. Because I do need to modify things. Does that build? No. Oh, because I didn't pass in the... This is the problem with code duplication, right? Here it is. Okay. And now down here, we can say this, println this self find AND gate of X wire and Y wire. But wait a minute, I'm passing in a gate. I don't need that. Yeah, I was trying to do it so I could pass in the gate type, but that's not going to work. Yeah. Okay. We do want to return the output as well. It's still because I'm not using it yet. Okay. All right, and we try to do it with the AND gate as well, and see if we can get all the information we need. And then we should be able to figure out what we're doing. Yeah, macro, macro, macro. That's the way to do it. Does a macro? Yeah, a macro allows you to do like uppercase and lowercase, right? In Stringify, you can do Stringify and then somehow convert it into a... All right, I'm going to worry about the macro later. So SJD. So we know that SJD is okay. So we want to be able to find an SJD or the previous... Right, this one's correct. So we know that we're going to get a value that's going to go into the OR gate. And the OR gate is going to have an output from this. The thing we don't know is the name of these guys, because it's coming from the previous carry. I guess what we can do is look. Oh, sorry, not the QMT. The QMT is coming from here. The GTN is coming from the previous one. So this is coming from the previous values OR gate. But we know it's just the output values that are swapped. So as long as SJT is going into an OR gate, then that's okay. As long as CDS is going into an XOR and an AND gate, then it's okay. The problem is the RTS. The XOR gate is supposed to output to a Z here. Oh. because we can look these two things up. We can look up the AND gate and we can look up the exclusive OR gate. We get these two values, SJD and CDS. CDS has to be exclusive ORed with something and have an output of a Z. So what I want to do is find any exclusive OR that has this as the input. Do I even care? I do want to get this value, and I do want to get this value. And SJD we could be, yeah, that's the other thing. We could be swapping outputs between two bits, right? Like let's assume that we fix this. All right, this should be Z07 and this should be RTS. We could be swapping like JMK and NPH, right? If those two are swapped, Scoop says, "Learn yourself up, buddy." Yeah, I don't. I now I'm questioning whether or not I need these things. If I know this is the pattern, so I should be able to find out if this is going to the right output, and it should be going into an OR gate. Right? If that's going into an OR gate, then we're okay. I don't care about the other side. Then I can look for the exclusive OR and see that it's going into an exclusive OR gate and an AND gate. We can also check to make sure that the exclusive OR gate and the AND gate have the same carry. Oh, maybe we could do it that way. I do want to be able to say, okay, I have an output. Which gate is it going into? And then return the whole thing. Right? Not compare left and right, but just say, what is it going to? So I can say find gate self wire stir, and this will return an option, also a string and a gate. And this will say find any gate with wire as an input. Right, so I can say for KV in self system, if matches V gate and left right, if left equals wire or right equals wire, or it could be the or it could be exclusive or, right? Return sum KV. None. All right, so this finds any gate. And now I should be able to do that here. Let output and gate is equal to this, which finds the AND gate. Oops, unknown. Oh, because I have this. Still unknown. Oh, let sum else panic can't find AND gate for X wire, comma Y wire. The other ones we can't panic for, but I think we can do that because we need to be able to find the these values, right? So now we can say let output needs to go into other gates. I guess we need to find all of them. So instead of option here, we just do a vec. Right, and now what we can do is find the gates. That it goes into. Self find gates of output. Should be a vec for G in gate lists. I'm just printing them out at this point. Println G. Let's see what we find. Okay, so we can see that SJD is going to this OR gate, right? And it's supposed to go into an OR gate, so that's okay. MQN is supposed to go, see? Oh, that's interesting. Z26 needs to go into other gates and it doesn't, right? Because this one's backwards. This one's swapped with one of the others. So we got to figure out which one. And then here, it looks like we have to swap these two values. That's pretty, this one's easy, right? We can figure this one out directly. That, oh, we ended up with two different gates that look like they need to be swapped. Maybe we swap CWH and Z34. Or something. Oh, I don't know. Actually, no, that's probably wrong. Okay. So now we know the names of the other gate, I guess. The input, so Z07 is the output of this guy, right? So we take the SJD and NPH and output to Z07, and this should not be a Z. That's part of the problem. Okay, so now we need to find the, we need to find the exclusive OR gate. And it's basically this. Let's see what happens if this shows something. And actually, it's the same code here. We just want to look at them. Okay. It's not panicking. That's a good sign. So we are actually finding the things. So now we know that CDS, which is this thing here, needs to go to other gates, and it needs to go into an exclusive OR into an AND. And the output of the CDS exclusive OR has to be a Z something. So if it isn't, then we know we messed up. So can we do that? And then we have CDS with the exclusive OR gives us the carry bit from the previous one. You can see that here. And that needs to go to, yeah, right, that needs to go to a Z. And then this other CDS has an and that needs to go into the OR for here. Okay. So maybe what we could do is write a get other input down here for gate. String. And say match self. Because what we want to do is, I know SJD, I just want to get the other input of NPH. So this is A and B, and this, we shouldn't be getting that. Oops, sorry about that. So we should say if wire equals A, then B, else A. Whoa, that looks ugly. Oh, I have to toString all these guys. If I return this, can I do that? Will it allow me to check things like that? Right, okay, so now what we need to do is say to get the other input for this guy. There should be one OR gate that it goes into. Oh, and if it doesn't go into the OR gate, then that's the output that needs to be swapped. We should see, yeah. This needs to go into a single gate. And it has to be an OR gate. But what do we do if it's wrong? If g.len is not equal to 1? Because I think, yeah. Here's a place where g.len is not equal to 1. It's 1 here, it's 1 here, it's 0 here. Oh, interesting. Z26 doesn't go into any gate? Is that true? Oh, it goes directly into an output. That's interesting. Yeah, I don't see an easy way. Why is this not allowing me to swap back? I don't see an easy way to do this programmatically. We pull up the AND gate, but what if we don't find anything? And we have to deal with that situation. If the gate list is empty, then we know the output this output is wrong. It needs to be swapped to something else. But how do we know what to swap it with? I guess we are getting the names of all the possible swaps. Maybe that's going to be sufficient. Maybe we get all the names of all the possible swaps, and then we just swap them randomly until it works. Right? Because we have SJD, we have Z07, we have NPH, and we have RTS, and we have CDS. We have all these guys. And these are all outputs. So maybe we just collect them and then just try swapping them and see if it works. So So far I've looked at the AND gate and the exclusive OR gate. There are these two other outputs that we need to find. Oh no, we grab the output here, right? SJD, CDS, we have those two, RTS, NPH, and Z07. Okay, maybe this is sufficient. Maybe we can just brute force it. Let mut output list is vec new. So we're going to say output list push output. Is this a string clone? Like that. And then here, instead of in the gate list, what we'll do is grab, I guess we don't care about the gate. We'll just do this. This is also going to be a string. Output list push gclone. And we can do the same thing here. I guess we don't care. We don't care about those. Okay, and now here we can say possible swap candidates output list. Maybe not. Maybe we need more. I don't know. So now we can try swapping for I in 0 dot dot output list len -1, for j in I plus 1 dot dot output list len. And I do have this thing swapper, but I just add them. Probably can remove it as well. Okay, let's just brute force this thing. Self swapper add or insert output list of I, output list of j. And then we're going to recalculate. Right? And then we just compare it here. If it's not equal to, then, if it is equal to, then we found our pair. Is this and this. Break out. Okay. Otherwise, we want to remove self swapper, remove output list of I. And I probably have to do random things regarding cloning and stuff. Probably have to clone these guys into here. Or Clippy will tell me I don't need to. Thread main is overflowed its stack. Really? Println. I'm going to quit out as Clippy because apparently we have this infinite loop here. Println swapping end cargo run tail. Swapping SDJ and Z07. Oh. Yeah, so it's this code that's broken. My swap code. I didn't even test to see if it would work, right? We should be able to get RTS and Z07 swapped and then get, what's wrong here? We're passing a wire. If we get the wire that has a swap, I need to put in both. I need to put both ways in. And then remove both. No. Okay. Oh, wait. It kind of started working. Why did it work on this one first? I'm confused why this isn't working. Oh, it's probably... No. If I do this, let me comment this out and put this back in. I mean, it should be... Why isn't it finding the first pair anymore? Let me do this also. Oh, because I'm doing tail. That's why. There. Okay. That explains that. So it's trying to do all the different swaps, and then it's panicking. When I try to actually use my swap bits here. So it's saying swap SJD and RTS, and I think that's right. Oh no, that's wrong. We want to swap SO7 or RTS. So I mean, swapping these two made it work, even though it's wrong. Oh, I'll need to check both ways, right? For X and Y. If sum is not equal, then we want to continue. This, and then we want to check X as well. Yeah. So we want to set let self X equals sum 1 dot Y, self Y is equal to sum 0, and then we want to get the number and make sure it's equal to X. Or it's equal to Y, yeah. Okay. And then we want to compare it with both. And it should be equal to Y plus 1 here. Otherwise, we found a pair. I guess I still need to break out here. Found pair. Okay, builds. Oops. So I found bits. Oh, am I still swapping these things? I am. Oh, is that the, no, that's, why would it continue? Okay, first of all, it said found pair and then it didn't break. I forgot to put the break in there. But it looks like it's still swapping the wrong values, right? Shouldn't we be swapping RTS and Z07? Why are we trying to swap SDJ? And then after we do that, of course, it breaks the next bit and overloads its stack. Okay. Maybe I got something wrong here. Maybe I just got to double check this part here. Just make sure it's set correctly. Nope, not good enough. Is this true? If I swap those two, it's going to work? Because this shouldn't come out correct. Okay, let's see. Let's see what this is giving us here. And maybe I need to check zeros as well. But that doesn't make sense. Zero is always going to be zero. Yeah. So we expected 128, and as soon as we swap these two, it ends up with being 128. So it ends up being correct. So we can't just swap and say, okay, that's good enough. Because it breaks the following bit. We actually need to check to make sure that the structure is right. So much for brute force. We could try finding, well, let me actually put that all back. We could try finding all the candidates for swapping. I'm just going to remove them for now. And then see if that gets us any closer. Okay, so it did find the correct pair eventually. It's just that that wasn't the first pair that it could swap and get the right value. Bit 8 is broken though. Why is bit 8 broken? I removed the swap list. Unless there's a code path where I forget to remove. Okay, we can find that out. If y equals 8, println self swapper. It should be empty. It looks like it isn't. It is empty. So how is bit 8 broken? That wasn't the broken bit from before. Let's see if we can go all the way back. No, I've lost the broken ones. All right, we're going to do it this way then. If y is less than 100, continue. I'm just doing it this way so that Russ doesn't complain. Yeah, 7, 12, 26, and 34 are the only ones that are broken. But if I go through this code here, somehow it breaks. And swapper list is empty on 8, right? But if I look at this, why would, how are we modifying things here? We're doing a find and gate, we're doing a find gates. These all pass in immutable references to self. Now I don't know what broke. Okay, let's try moving this down here. Oops. Right here. Just print out the swap candidates. Yeah, that works. So something in this loop breaks things. No, I don't need to do that. Yeah, somehow bit 8 now is broken. Oh, I know why. I know why. Because I set this here. I gotta set it every time. Okay. Yes. Was it bit 12? I don't remember now. Yeah, 7, 12, 26, and 34. Okay. All right. We do find it eventually. So maybe what we do is we save all of these and then we try them all. So we'll say like possible pairs. And that's just going to be a vec. And we'll just save it. Possible pairs, push these guys, right? No, like this. Are you concerned you don't find anything in bit 12? Yes, I am concerned about that. How would that be true, though? Is it the case where, yeah, the output from the previous bit is a problem? And that's where the issue is, right? Okay, so let's let's just find them all. And let's get rid of some of these print statements that are making it noisy. We'll leave the swap candidates there. And that, okay. Bake and run. We're still getting a Stack Overflow. Let's get rid of this line here. Where is it? This. Main is overflowed stack. Why? Because we finished. It shouldn't have gone any further than that. So we're swapping here. Oh, I wonder if by doing a swap, a random swap of outputs, it's causing an output to go into an input, and that's ending up. So we actually need to check for that and make sure that we don't try to wire an output into an input. Can we say, yeah, let's rename this to output and put a gate here and then check to make sure that the gate doesn't. How would that self wire? We can look at the these things here. CHV, FQF, Z34, right? If I swap CHV and Z34, it would mean Z34 exclusive OR with FQF. Would output to CHV. I mean, is there a way to check that? That we're not going to swap it in. Scoop says get value can have a depth and return none. Yeah. Yeah, that's true. But then, yeah, so the sum, then maybe I just make the sum max int, avoid having that to be an option. If let sum v is equal to self get value wire, then this else return U64 max. And that way the sum will be wrong. And now I'll have to pass in a depth here, right? We know we have less than 313, right? Less than 313 gates. So we shouldn't have to go further than that. Let's say 1,000. Oh, this should be V here. Right? System len. Would that be sufficient? Probably. To find out. And then if depth equals 0, return none. Okay. Okay. And then this has to be sum. This is probably going to expand this into multiple lines. Oh, no, it didn't. It still doesn't like it. Oh, because these are options now. Question mark? Almost. Because we can put the sum around the whole thing. Okay. Well, we found something for 12 now. So that's good. I wonder if we can get away with these three. And if we found these, okay. I wonder if that's okay. No, I don't know if I'm just lucky here. Let me try putting these four in. It's weird that they only have the Z's because I would have expected there'd be at least one where the swap would be something like this. We are expecting 8 wires. Okay, well let's see what happens if I put these in as the swaps. Ignoring this guy. Which is always going to be the first one. So we can just, this is hard coding. Visible output. So we're going to just say for pair in possible 1 ... self swapper insert. And this is just oh, interesting. It's a vec of options. It should be just 2, right? I should be able to say pair. I thought I was going to say pair 0 clone, pair 1 clone. That's what I thought I was going to do. I guess I am going to do that. And then now with that inserted, we should be able to set X and Y to 0 and have the values summed up. Actually, we should do that, right? Where am I? So I should be able to do this now and sum them up. Yeah, sorry, yeah, set to none. And that way we can get the values themselves, and we can say println let sum x equals self x. Oh no. Sum y equals self x self y. Println sum x plus y. I'll put a space there. Is equal to x plus y. Oh no, sorry. Else panic. Oops. Like that. So it definitely came up with a different number. Let's see if it, with all of these swaps in place, we can get the number now. Self z is equal to sum. No. Self get number z. And then println. Oh, not self z. Nope, it didn't work. So those, I'm not finding the right things to swap, is the bottom line. Okay, which probably means that probably means I do need to go to bit 11 and 25 and 33, right? How far can an error propagate? More than one? Or just one? This is the number we're actually looking for based on the values were input. This is the value, this is the number it came up with the incorrect swaps. We tried to fix it and failed. Let's make sure that I have all the swaps right. I should. I mean, there's no reason this should be wrong, right? So JPJ with Z12. Yep. Z07 RTS. This one I think we know is the correct answer. Let's look at bit 12 and see what it's supposed to be. X12. Y12 and X12. Y12 and X12 go to MQN. And then we need to look for the exclusive OR. And that goes to NFT. And then we need to look for MQN. So that looks right. And we have to look for NFT. And then there should be an AND in there as well. Okay. I mean, this looks like these two were swapped, JPG and Z12. That seems right. Right. Okay. So let's just look at it this way. We have X12 and Y12 going to MQN, and that gets brought down to the OR, which it does. We have the exclusive OR going to here, and that goes to both of the exclusive OR and the AND, and we bring in the KSN from the previous bit, which I'm assuming is, I don't know if it's correct or not, but it's going to Z12. So these two need to be swapped, and that was one of the things we did find. What happened to my, oh, it's in Bacon, cargo run. That was one of the swaps we found. Okay. So let's check out 26. This is the doing it by hand business. We have an exclusive OR, but we need the AND as well. Here it is. So Z26, that's wrong. We do need BVP. And GDB, and then we need another one. Okay. What about STC? BVP and GDB goes to STC. We can have that one already. And then we have the OR here. We're missing it, the exclusive OR of this guy. So maybe it's under GDB. Yeah, here it is. Put it in the same order. So here it looks like, oops, here it looks like Z26 and KGJ got swapped. right? Because this needs to go, yeah, here. And this needs to be the output. So let's see what happened here. Yeah, that's right. But it's the lower bits that are, oh wait, it worked. Wait a minute, it worked. Why did it, okay. All right. um, we do have an extra thing here, but I think it's working. Let's see what happens if I put in this as our answer. All right, the way we get the answer is we say self swapper keys self swapper keys collect vec and keys sort, and the output is keys join by comma, right? That's what we care about. Method join exists for struct vec string, but it's something 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 bacon clippy. We'll just keys vector reference to string. Why can't we do that? I have to do a cloned. So this is my answer. Kind of hacky, but let's see if it works. Not the right answer. That was right. Every single one of the, I didn't check this last one. Okay, let's check the last one. X34, Y34, and X34. And then we want exclusive OR. And then we want to take a look at this is a correct example. So CHV that's wrong. I mean, the output's right, but this should be going into the OR. Right, and then we need an OR statement. The OR takes the top and the output of the AND. So CWH here. Okay. So it looks like CHV is wrong. And so I'm just looking up here. So the AND should go into the OR, and it's going into the pair here. And the VVW is going into the OR, and it should go. So these two are swapped. Okay. Then how did it come up with the right answer? Or maybe I misread what I was seeing here. Doesn't that look like the right sum? Oh, wait.
It's not always finding the answer. How can that be? How can that be? Now bit 12 didn't find the thing. That's probably what happened last time, right? But at least we now know what the answer is. Right? CHV and VVW. So we can actually put these in here now, which is bad. Let's do this. We can do it this way. For pairs in, we're going to do Z07 RTS, Z26 and KGJ, Z34. No, this is the one where we have to do the other thing. CHV and VVW. And then we're missing the bit 12. Bit 12 is sorry, for bit 12, what do we have backwards here? This is the correct pattern. So this goes into the SSV goes into the OR, MQN goes into the OR, and QMT goes into this pair, which it does. The exclusive OR should be the output, so it's Z12 and JPJ. Maybe we can do it this way. Cargo run. All right, so this is my final answer, and it looks like it's coming up with the correct solution. This one is not, so I'll have to play with it, but I think this is the right answer here. Yeah. Okay. So it's still broken, but I can think about maybe different ways we can clean that up. Git status. Git commit -m 24 day 24 part 2. I do need to go. It's a little over time for me.